Alright, one of your papers is asking you to find the reference angles of a whole bunch of angles. They give you some kind of drawn out in standard position, and then in others they give you just the angle measures. Some of them are in degrees, some of them are in radians, and a lot of them are negative. So since you have these types, we're going to use the negatives, that is, we're going to use the coterminal angles. Now remember, if it's in degrees, let's leave it in degrees. If it's in radians, let's leave it in radians. So the very first one here, which I haven't drawn all that great, but hopefully you get the idea. By the way, I didn't draw it every single time, but remember that the positive direction of the horizontal is always the initial ray. Oops, that wasn't very good, was it? The initial ray here, the initial ray, the initial ray, that one's in, and the initial ray here. Oops, not very good. There we go. That's what it means when it's in standard position. So in this case I have a negative angle. I definitely can tell it's in the second quadrant, but I have a negative angle, and that's no good. So I am going to add 360 to this. If I add 360 degrees to this, I am going to get, looks like 105 degrees. Now these are two different angles, but they're coterminal angles, and because they're coterminal, they'd have the same terminal side whether I went this way 105 degrees or whether I went this way negative 255. These two angles, although they are not the same size angle, they are coterminal angles, they have the same reference angle. The reference angle in the second quadrant for degrees is 180 degrees minus whatever the reference angle is. Set this equal to the 105. So 180 degrees minus alpha is equal to 105 degrees. Subtract 180 degrees from both sides. Hopefully you can see this. I get the opposite of alpha is equal to, be careful with your arithmetic, negative 75 degrees. That means my reference angle is 75 degrees. That simple. Here again, I have a negative measure. So I don't want this angle. I want a coterminal angle. I want this angle here. So I'm going to add 360 to this one as well. And I'm going to get, looks like 230 degrees. So in the third quadrant, remember for degrees, it's 180 degrees plus the reference angle. This being the reference angle right here. So 180 degrees plus the reference angle, set it equal to 230. Subtract 180 from both sides. This one's nice. One step. And I get my reference angle is 50 degrees. In problem number 3, I have a first quadrant angle. Now it's first quadrant, but it's negative, so just like I did on the last two, I'm going to make it a coterminal angle positive by adding 360 to it. Now if this was like a couple spins around, I might have to add 360 more than one time. But if I add 360 to this, I'm going to get 80 degrees. And 80 degrees is between 0 and 360. And in fact, it's this angle right here. Well, it's in the first quadrant, so it's its own reference angle. Nice. Okay, problem number 4. My first angle, that's a positive value, which is great. It's in the second quadrant. I don't have to add or subtract 360 or anything like that. I'm going to leave them as is. And then I'm going to figure out what this angle is right here. Well, you can see they're going to be supplementary angles because in the second quadrant, 180 degrees minus my reference angle, I set that equal to 165 degrees. I subtract 180 degrees from both sides. I get the opposite of alpha is equal to negative 15 degrees. I get alpha is 15 degrees. There's my reference angle. Now all of a sudden, the next 4 examples are all in terms of radians. You don't see any degree signs here, and they all have pi in them, which is usually a tip-off. It's in radians. And as you can see, this one here and this one here, negative angles. So instead of adding 360, I want to add on the radian equivalence of 360 degrees, and I know that 360 degrees is equal to 2 pi radians. So I've got a little bit of arithmetic here because of this fraction. Don't get a calculator out and change it to a decimal. I am going to add 2 pi radians, which I'm going to put over 1, to negative 29 pi over 18. Now I'm in the first quadrant, so this is my angle that I'm looking for, and that's going to be its own reference angle right there because I'm in the first quadrant, but I have to get a common denominator, which would be 18. So I get negative 29 pi over 18. Multiply top and bottom by 18, I get 36 pi over 18. And then add the numerators. I have negative 29 pi and a positive 36 pi would be 7 pi. And that's all over 18, and that's in the first quadrant. And that is its own reference angle. That's my reference angle right there, 7 pi over 18. Now this guy here, he's positive. He's between 0 and 2 pi, but he's in the third quadrant. I need this angle right here. That's my reference angle at acute angle. So remember, in the third quadrant, it's 180 plus my reference angle, or in this case, pi plus my reference angle, that I'm going to set equal to 13 pi over 9. I'm going to subtract pi from both sides, and I get alpha is equal to, now, 13 pi over 9 minus pi, which would be like pi over 1. I have to get a common denominator, which would be 9. I'm going to have to multiply top and bottom by 9. I have 13 pi over 9 minus, multiply top and bottom by 9, 9 pi over 9. So subtract, that's 4 pi over 9, and that's my reference angle right there. That's that acute angle. Well, just like problem number 5, first step is to get an angle that's positive. So I'm going to add 2 pi to this. So I'm going to just do some work up here so there's more space. So I'm going to take negative 31 pi over 18, and I'm going to add 2 pi to it, which is like 2 pi over 1. Common denominator would be 18. Negative 31 pi over 18 plus 36 pi over 18. I multiply top and bottom by 18. I add the numerators, that's 5 pi over 18. And notice it's in the first quadrant. Not only is that the angle right here that I get when I add 2 pi to that, that's my reference angle. My reference angle is 5 pi over 18. Alright, one more to go. It's positive, so I don't have to add or subtract. It's positive in between 0 and 2 pi. I don't have to add or subtract 2 pi from it, but I'm in the fourth quadrant, and in the fourth quadrant it's 360 minus alpha, or in this case, radians, it's 2 pi minus alpha. So I'm going to we'll work up here. 2 pi minus alpha has to be equal to 29 pi over 18. That's going to give me this angle right here, and I know I've got it drawn so that it looks like it's negative, but the actual positive measure of that angle, and that's going to be my reference angle there. So I'm going to subtract 2 pi from both sides. I get the opposite of pi is equal to 29 pi over 18 minus 2 pi, or 2 pi over 1. So I get the opposite of alpha is equal to 29 pi over 18, multiply top and bottom by 18, minus 36 pi over 18. So that I get the opposite of pi is equal to negative 7 pi over 18, which means alpha is equal to 7 pi over 18 positive. There's my reference angle. You can't have a negative reference angle. If you have a negative, you messed up somewhere in your arithmetic. Be careful, go back and check. Now, these next 6 problems, they don't give me the drawing. So you say, well, how do you know what quadrant you're in? Well, we'll start out with this guy, 260 degrees. Remember, I'm going to just use this diagram. This is 90, 180, 270. 260 is between 180 and 270. So this is in the third quadrant, which means that 180 plus my reference angle is going to equal 260. Subtract 180 degrees from both sides, and I get alpha is equal to 80 degrees. There's my reference angle. See how easy that was? You just recognize knowing all your quadrantals. 90, 180, 270, 360. Pi over 2, pi, 3 pi over 2, 2 pi in radians, which I'm going to have to do down here. Now, next guy up, 140. Well, that's between 90 and 180, right? So that means it's in the second quadrant somehow. I don't have one that looks like that. So in the second quadrant, I know that it's 180 minus my reference angle that equals the second quadrant angle. Subtract 180 degrees from both sides. I get the opposite of alpha is equal to negative 40 degrees. I get alpha is positive 40 degrees. There's my reference angle. Now this one's not so bad. 245, I was just kind of talking about an angle close to that before. That's between 180 and 270. That puts me in the third quadrant. It's positive. So I'm going to use the same thing I did up at number 9, 180 degrees plus alpha, and I'm going to set that equal to my angle 245. Subtract 180 degrees from both sides. 65 degrees, that's my reference angle. This is very similar. Look, 220 degrees. That's also in the third quadrant. It's between 180 and 270. So I set 180 degrees plus alpha equal to 220 degrees. I hope I wrote that problem down right. Maybe it was negative and I forgot to write the negative down. I'll check in a second here. I get 40 degrees for my reference angle. Let's see. Did I write it down incorrectly? No, it says 220. Alright, now the next two guys up are both negative angles and they're both in radians. So just like I did back here, if it's negative like it was here, like it was here in problems 5 and 7, I'm going to start off by adding 2 pi to the angle. It's going to give me a different angle, but it's going to give me a coterminal angle and they'll have the same reference angle. So the common denominator here is 6. This would be 12 pi over 6, so I add, and I get negative 11 pi over 6. Uh-oh. First time this has happened. It's still negative. Add on another 2 pi. I keep on adding 2 pi's on until I get a positive. So this is the same as 12 pi over 6, so I have negative 11 pi over 6 plus 12 pi over 6. I get pi over 6. Well, that's positive, and notice, not only is it positive, it's in the first quadrant. Remember, this is 0, this is 90, which is pi over 2. Pi over 6 is between 0 and pi over 2, so it's in the first quadrant, and it is its own reference angle. So the reference angle of the original problem has the same reference angle as this guy down here, pi over 6. That one was kind of neat because I had to add 2 pi twice. You might have to add it more than twice, hopefully not, but you never know. This next guy here, it's negative. I'm going to add 2 pi to it like I did in the last example, hopefully just once. Looks like just once. My common denominator is 9, so I'm going to multiply top and bottom by 9. And then I'm going to combine and I get 13 pi over 9. Now 13 pi over 9, you look at that and you say, what quadrant am I in? Let's go back to one of these drawings here. This is pi over 2, this is 180 or pi. Now this is bigger than pi because 13 divided by 9 is bigger than 1. This is 270 is 3 pi over 2. Is this bigger than 3 pi over 2? Does that put me in the third quadrant? Well, 3 divided by 2 is 1.5 pi. 13 divided by 9, did I bring my calculator? Of course not. 13 divided by 9, you just do this on a calculator. Goes in once, 40, goes in 4 times. Well, that's less than 1.5 pi. So this is going to be in the third quadrant. My relationship in the third quadrant, do I have it anywhere? There it is, pi plus alpha. So pi plus alpha is equal to 13 pi over 9. Subtract pi from both sides. Alpha equals 13 pi over 9 minus pi, or pi over 1. I'm going to multiply top and bottom by 9. I'm just going to be lazy and put a 9 here and a 9 here. So that gives me 4 pi over 9. And that's my reference angle right there. 4 pi over 9. And that gives you the approach to the first 14 problems. Now, you also have some, and there's more of these angles. By the way, I'm not completely done. I think I probably have given you enough, though, to get going. You also have these things here. Okay, let's start off with this one. This is the first one that they give you. Look at all the blanks they want you to fill in. Okay, this is the angle. Now they tell you which one's which. Degree for dash, so this would be 0. This would be 0 radians. 30 degrees, pi over 6. 45 degrees, pi over 4. So you put the angles on the inside, and then you put the sines and the cosines and the sines, the x and the y on the outside. You do that on this one. You do this on this one. Now let's see, does it say the same thing? I think it says the same thing. And you do that on this one as well. He's given you 3 different ones to practice this with so that you can memorize all this stuff. Okay, there's patterns. It's not as bad as it looks. You just got to get after it a little bit, okay? Then, you got this guy here. I don't know if maybe you guys did this in class together, but you've got some angles to fill in there, some values for the angles to fill in there as well. That's back from the first quadrant, the first video. Oh, wait a minute, hang on. This one's even got a couple of spots to fill in, so don't forget to fill in the spots here for the sine and cosine here. For the three angles, this is also back from the first video. Okay, then you've got 3 pages, count them, 3 pages of reference angles to find. Now I have done the first 14 of them. You have a grand total of 32 of them. But they don't look any different in some ways, and at least the reference angles. Oh, you know what? I got to read the directions. Okay, these last ones are not reference angles. These last ones are finding the sine or the cosine. Here's where memorizing comes into play, because you'll be able to find these values not from drawing 30, 60, 90s or 45, 45, 90s, but for knowing that the sine of 150 degrees, is that 150? No, it's 135 degrees, is equal to the square root of 2 over 2. You've got it in the unit circle that you've created. You've got to memorize that. You should be able to get all of these. Now there's a tangent there, so that one's a little sneaky. That's the only one I see on that page. Oh, there's 2, 3, there's 4 tangents on the back page. Remember, the tangent is the sine of the angle over the cosine of the angle, and you simplify, because they mostly will simplify pretty nicely for you. So use your unit circle, but make sure you've got the unit circle memorized. I keep telling my calculus students that they've got to have it memorized, and most of them don't have it down yet. I've told them about the left-hand rule. I've begged them to watch videos that help to explain it, and they're still procrastinating on it. Their AP exam's coming up in about 5 weeks. They got to know it for that. So you're going to get a jump on it here. You can practice these and memorize these. And of course, if you have any questions, I'll be happy to help you.